Hi, Professor Dyer here, talking about research in human development and family science. I want to briefly describe the statistic that is used to convey how confident the scientist is in the precision of their estimate. So they may be presenting statistics such as proportions or averages. How confident are they that proportion or that rate or that mean represents the entire population, not just the sample that was being studied? This is what's called a confidence interval. Um, as I said, all the statistics we've talked about so far are describing simply the sample that was studied. But we only study a sample because we think that it's going to represent a larger population. So the confidence interval is about making that transition from this sample to the population at large. I want to point out to you that you've heard of confidence intervals before, even though maybe you haven't heard that term. Every time you see a political poll or any kind of opinion polling presented on the news, let's say, here's one from years ago. I didn't want to get into any contemporary politics necessarily, so let's look at an old example. We have candidate A, candidate B, candidate C, and there's been a sample of people who were called to ask, who are you planning to vote for in the presidential election? And they've all made their case. Notice the very bottom says today's sampling error is plus or minus 2.5 points. Plus and minus 2.5 points, that is a margin of error, which produces a confidence interval. So what that means is we can say here, Bill Clinton at the most recent date, it looks like, was polling at 51%. So 51% of people who were polled said they were going to be voting for him. How sure are we that that is an accurate representation of the population and where they might vote? Well, how sure we are is we take 51% and we subtract 2.5 points from it, and we add 2.5 points from it. And that gives us a confidence interval. Those two numbers are the interval. And we are 95% confident that the true number is within that interval. That's conceptually what a confidence interval is. The certainty that we have that the general population, but notice that it's this transition from the sample to the population that we're talking about here. Now, most of that comes from having a representative sample. And so that refers back to what we talked about in terms of sampling strategies and choosing sampling frame that represents the population and so on. So when we present confidence intervals, we are assuming that we're talking about a representative sample. We have good reason to believe it's a representative sample. It intends to be a representative sample, and we have good reason to believe that it has in fact achieved those goals. But even with a representative sample, there's going to be some just kind of random fluctuation, some random variation, which we call error in the data. So it's not going to be perfect. I mean, flukes happen when you sample, you take a sample. If the sample is small, it may, and you happen to just because of a random fluke, you happen to call 5 people in a row who all have a really extreme position. That sort of random fluke happens. And when the sample is small, that little fluke can really affect the mean. The larger the sample gets, those flukes kind of dissipate, and there's just so few of them and so many more normal reactions that they disappear. So this is going to be about taking a sample based on that sample size. How likely is it that there are flukes that are going to be kind of distorting the results? And it's trying to estimate that. So we want the confidence interval to be small so that our estimate is more precise and we can be more sure about it. How do we get those small confidence intervals? Bigger samples and more precise measures will do it. So this is an interaction really of the sample size with the precision of measurement and how much variation there is just naturally on the thing that we're measuring. Here's a more recent example. Notice at the bottom, it says their margin of error is plus or minus 3.7 percentage points. So I wanted you to see a bit of a contrast from a relatively small confidence interval in a political poll to a slightly larger confidence interval in a political poll. And my guess is that that's because they had a smaller sample size. The first poll, they asked one question, who are you going to vote for? And in this poll, they asked, it looks like 6 questions. And people are less likely to stay on the phone for 6 questions than they are for one. And so you end up with a smaller sample size. And so there's more, there's less precision in the estimate. And that means that the confidence interval is slightly larger. Let me show you what it looks like in a research article. Often in a research article, confidence intervals are depicted with these little flags. Do you see attached to the end of each bar, each yellow bar? So this is a study of poverty in Switzerland. Unfortunately, in the United States, our poverty rate is much higher than this, but it looks like in Switzerland, their poverty rate is maybe 6.5%. Ours is quite a lot higher, but they're looking at poverty in different populations. And so some of their estimates are very, very precise. They know exactly, very close to exactly what the poverty rate is. Let's say, look at the yellow bar for employed persons. It's about 2/3 of the way down. And it's a yellow bar. Employed persons have a poverty rate of, it looks to be maybe 3%. But look how tiny, tiny that confidence interval is. They're very certain about it. And since most of the people in their sample were employed, they have a huge number of employed people. So that estimate is based on a huge sample size, and they can be very, very certain that the estimate is correct. Right below that bar is unemployed people, and there were many fewer unemployed people. So we know that unemployed people have a higher poverty rate. It looks like their poverty rate is maybe closer to 13% or so. So we can tell that it's higher, but just notice that the confidence interval is a bit wider. We have less precision in that estimate. We don't know exactly where it falls, but it falls somewhere between these two kind of nodules on the end of that bar there. That's a use of a confidence interval. So if you just glance over this, you can see some things that have very small confidence intervals. On gender, well, if you look at women and men, those two yellow bars kind of near the top, those confidence interval bars are very, very narrow, but look how wide the confidence interval is when we're estimating poverty among individuals age 65 and older. Maybe they just didn't have a lot of those in their sample, and so it's harder for them to make a very precise estimate. It's also quite large on the estimate for single parents with children. We can see that they have more poverty than two-parent families, but apparently there weren't that many of them in the sample. And so the confidence interval is very, very large on a few items. So that's how confidence intervals are. We often see them appearing in scientific research. Overall, I would say that estimates, and not just numerical, but also categorical data we come up with these results that are presenting what happens in a sample, but the reason they do that is because we're trying to estimate what the prevalence might be in the whole population. So this is making the jump from the sample to the whole population. The confidence interval is then a measure of how certain we can be that the estimate is true in the whole population. So all of this is based on some statistical variables such as the sample size and standard deviation, and they're estimates. They're not certainties, but we have reason to believe that they're pretty reasonable. And so we're trying to say this is how precise this information is, or this is how precise this information is not. Smaller confidence intervals represent more precision. And we get small confidence intervals with large sample sizes and less variability in the underlying construct being measured. All right, well, I hope that helps a lot. Confidence intervals are not a particularly easy concept to understand. For the purpose of this class, please just have a general understanding of what that concept is trying to get at. You don't need to know a lot more detail other than that, but in your mind, be sure that you can distinguish conceptually how a confidence interval is different from a standard deviation, because they're not the same thing. And just kind of think about how they are different from each other and conceptually what they're trying to do. And that's the level at which you need to know this for this class. Okay, thanks.